Hey YouTube, it's been a while. In this video I want to build a new version of my slot mortiser. It was over 10 years ago that I posted my first video on YouTube showing off my original idea of this jig, so I thought it would be fitting to jumpstart this channel by recreating this very useful and fun to build jig. Let me show you some of its features. Well, I think the main feature is the ability to quickly set the tenon width with these adjustable stop blocks. So you can make the tenon as small as a straight dowel and as large as 3 inches. Another great feature is the smooth motion from the linear rails. This ensures that the jig performs without friction or binding for years to come. Finally, an adjustable table allows you to accommodate for different material thicknesses while securely holding the workpiece. Alright, let's get into building this jig. When starting a project like this, it's easy to get overwhelmed with all the details. I think it's easier to break the design into smaller sub-assemblies that I can tackle one at a time. I'll start with the base. The base serves two main purposes: to support the XY motion of the router and to provide a 90-degree reference face to the router bit. The construction is pretty simple. I start by ripping some leftover plywood to width and then to length. The side supports need a little extra work. I use a jigsaw to cut out the shape, being careful to follow my line closely. The front face requires a mortise on the back side. This gives relief for the router to plunge deeper, allowing for a greater depth of cut. With all the features on each piece complete, I can now start assembling the base. I do need to follow an order of operations. First, I'll attach the side supports to the bottom layer. Then I can sandwich the second bottom layer onto that. Finally, I can attach the front face. And just like that, the base is complete. Before moving on, I want to talk a minute about linear rails and why I chose them in this application. Over the years of making woodworking jigs, I've learned that linear motion is usually a source of error and frustration. The movement typically works well at first, but as time goes on and wood shrinks or expands, guides wear out, the jig stops working as well as it did when it was first built. Moving forward in my jig building journey, I plan to incorporate these linear rails more often. They come in various sizes, offer excellent rigidity thanks to their preloaded bearings, and resist dust effectively. Now, I bought this set off of Amazon, and it came with two 12-inch rails and 4 bearing blocks. This will be all I need, but I'll have to cut the 2 rails in half. Since these are lower quality linear rails, they only have a small amount of case hardening where the balls ride, so I could just use my bandsaw to cut them. I wanted to give the living rails something flat and rigid to mount to, so I decided to make a series of mounting plates, one for each linear rail as well as one for the table support and router mount. All the operations needed to machine the plates are simple and could be done with a drill press, but since I have a CNC machine available, this makes things much easier. The plates do require precise hole location. While this could be done with careful layout, a CNC machine makes quick work of it. So this plate in particular needs a couple of the holes tapped for 1/4 bolt. That's because the router cradle actually bolts to this plate. The rest of the plates need to be tapped for 4mm. This is the size of the bolt that the linear rails are designed for. The XY motion of the jig is contained within a single assembly that can be dropped in and screwed to the base. It consists of linear rails, mounting plates, and some 3D printed parts. The assembly simply requires screwing everything together while ensuring all components remain square and aligned. Following the model, I installed the assembly flush with the back of the side supports and centered within the base. For mounting the router, I designed a 3D printed cradle that bolts directly to the mounting plates using some 1/4-inch cap screws. Finally, I can add a depth stop. I 3D printed a simple block with a 2-inch long slot and bolted it to the mounting plate. I then replaced one of the cradle bolts with a longer bolt that can act like a stop. Now I can simply set the router to the desired depth and lock the block in place. Before starting the assembly of a table frame, I first need to transfer the holes from this table support bracket to the wooden table support bracket. Assembly starts by mounting the linear rail to its mounting plate, and then I can bolt the metal table support to the bearing block. Next, I'll add the necessary features to the table's side stretchers. First, I cut an angled edge to one side, which is just purely decorative, and then I can use the CNC to cut a 2.5-inch slot for the table lock. Well, this could have been done on a router table. I don't have one, so CNC it is. With the table frame reinstalled back to the base, I can go ahead and install the tabletop. I want a strong, flat surface that I can easily clamp stuff to, so I decided on a 3/4 by 3-inch aluminum extrusion. This stuff will work perfect with my match fit clamps, as well as be pretty handy for attaching anything else to the table that I need to. The X-stops are completely made up of 3D printed parts. The construction starts with a rail system that is mounted to a plywood riser. I first mark the locking hole location on the riser and install some threaded inserts. With the rail all mounted, I can now turn my attention to the blocks. Again, the parts are all 3D printed, but do require some threaded inserts to be installed. With the blocks fully assembled, I can now install an adhesive back scale on the rail, and then lock the blocks in place using some 3D printed knobs. To calibrate the stops, I first need to cut a slot through the front face to the jig so I can mark the center line. Next, I'll align the rudder bit with the center mark. I can now slide my blocks in until they are touching and in line with the center 4-inch mark. Then I can carefully slide the rail under the blocks until the gaps on either side of both stops are equal and lock the rail in place. Finally, I screw in the adjustment screws on each side until they are just touching and then lock those into place. With the stops now set to the center line of the jig, I can set the secondary stops for the bit diameter. I set each stop to half the thickness of the bit being used. In this case, I've got a 1/4 inch bit installed, so I'll set each stop to 1/8 of an inch. Now the stops automatically adjust for the bit thickness, so all I have to do is measure the thickness of the tenon and set each stop to half of that measurement. So in this case, the tenon measured 1.5 inches, so I set each stop to 3/4 of an inch. The final step to calibrate the jig is to do a test piece. First, I need to mate mark the two pieces. I also wrote an X on one side of each mark. I'll explain why later. Next, I clamp the first piece into the jig, aligning the mate marks with the center line. Take note which side of center the X is on. And the fit check here feels pretty good. Now I do the same to the other piece. Now notice that the X is on the opposite side of center. This is important to realize because any error in the calibration of the jig will cause your mate marks to be off by double the amount of that error. So I actually didn't get this lucky on the first try. My first test was actually off by nearly 1/4 of an inch. Fortunately though, I was able to go back and adjust the rail position to correct it. Now it's within a 30-second, which is plenty good enough for me because in normal use, I would always make the mortise slightly larger than the tenon. Well, one thing this jig definitely needs is some dust collection, so I just modeled something up in 360 and printed it out on a 3D printer, and I'm quite happy with the results. As you can see, it's collecting like I'd say 90% of the dust it makes. This would be a good use case for this jig, mounting a stretcher to a leg. The tenon will be located in the center of the stretcher, but not in the center of the leg. So this means I need to mate mark for both the center of the tenon as well as the height location. Next, I need to make the floating tenon material. I like to purchase this hobby material from the big box store because it's already the correct thickness. I decided to use this stuff, which is 2.5 inches thick. All I need to do is cut it to length and round the corners with a plane. No need to get fussy here. Now to set the jig, I first need to measure the tenon width and move each stop to half that distance, which in this case is 1.25 inches. I just go a little bit more for a little wiggle room. Now I can set the height for the stretcher and cut the first mortise. Now I can go ahead and set the height for the leg and cut that mortise. With my tenon cut to twice the depth of the mortise, I can now do a test fit. Everything lined up perfectly. The thickness is a little tight, so I could sand it a tiny bit smaller if needed. Alright YouTube, that's it for this video. I hope you enjoyed the project, and I'm Ryan Odwell. Thanks for watching.